class, this is Algebra 2, Chapter 7, Section 2, and we're going to talk about inverses of relations and functions. So there's a reason why they name the section not just inverses, but they want us to do the inverses of what we call relations and also functions. So the first box that's given to me in this example here, or table, is a relationship or a relation between x and y. So we don't actually have a function for this one, we just have a relation. So it asks us to graph it, and then it asks us to connect the points. So let's go ahead and put this on the coordinate plane. Our first coordinate is x of 0 and y of 2, an x of 1 and a y of 1, 2, 3, 4, 5, an x of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, right here. And the final one is a graph of a point of 8, 6, 7, 8, and 9. 1, 2, 3. Okay. So these 4 points it's asking us to connect. This should look like a dot to dot, by the way, unlike the exponential functions that we graphed yesterday. And the next thing that it asks us to do, and I'm going to switch colors here, is it wants us to graph what we call the inverse. So the first part is very simple. So in your notebook I want you to write, to find the inverse of a table of values, switch the x and the y. So the first point is a 2, 0, because I switched those two. The second point is a 5, 1, because I switched those two. And on down the line we have a 6 and a 5, and a 9 and an 8. So if I graph the new relation, the inverse of the original relation, I'm going to graph 2, 0 right here. I'm going to graph 5, 1 right here. I'm going to graph 6, 5, 2, 3, 4, 5 right here. And the last point that I'm going to graph is 9, 8 right here. When you connect these, you should see that they create a line of symmetry that goes right through the y equals x line. And I'm going to add arrows to that. So typically, that line, you don't have to draw it. If you do draw it, just make sure you make it dotted or something like that so that we understand it's not really a part of the relation. We're just checking ourselves. But you should notice that the red and the blue line graph are perfectly symmetrical about that line, and that's the case for every inverse function. Then they're going to ask you to identify the domain and range, and that's what the last part of the directions tell me to do. So let's start with domain. Remember, domain has to do with the x values. So for the original function, my domain is all of the red values here. So my domain, which has to do with the x values, is all numbers between this point right here, which is 0, and goes all the way. So we start here, and since my function goes over here to 8, I'm going to use that as my right boundary. Okay, and the only reason I'm doing this is because it told me to connect the points. So my domain is between 0 and 8 of the original function. My range, of course, remember, range is y. This line just means in the set of. The y values for the red function go from here, that's my low point, up to this point, which is my top point. So they go from 2 to 9. Now, the cool thing about the inverse, and I'm going to go back to blue now, the inverse has a domain and range And all you have to do is switch, since we switched our x and y, your domain and range for your original function. So the domain for an inverse, we're still going to talk about x, is between 2 and 9. And my range is for y is between 0 and 8. And you just switch places. The graph also matches these values, and that's the first example. Okay, example 2, instead of giving us a relation or a table of values, it actually gives us a function and wants us to write the inverse. So we're going to write down the steps here. I want you to copy your notes just like this. When finding the inverse of a function, finding inverse of a function, finding inverse of f of x. We're going to, step 1, replace f of x with y. Alright, applying that step to our problem, we're going to take f of x, we're going to replace it with y, and we're going to leave all the other stuff the same. Okay, so I'm using this function, and I've just applied step 1. Step 2, I want you to write down. Step 2 is to switch x and y. So switch places, make x be where y is, and make y be where x is. And your last step, number 3, or step 3, sorry, there's 2 more steps. Solve for y. For our problem, solving for y looks like this. I'm going to add 1/2 to both sides, and that makes x plus 1/2. And the final step for writing the inverse is replace y with our new notation that looks like this. It has nothing to do with an exponent. That -1 actually means inverse, not an exponent. So maybe write yourself a note. It means inverse, not an exponent. So we're not taking anything to the -1 or anything. This is just our way of saying we just found the inverse of f of x. So the final step looks like this, where I saw y, and I'm just going to move y to the front. I replace it with f to the -1 of x. And that's how you read that, f to the -1 of x. And that's the answer. Okay, let's do another one of those. Let's call this example 3. Example 3 is giving us another function, and this one's a little harder because it has multiple steps. So our step 3, where we solve for y, is going to take just a couple of steps. So let's start with step 1. I've got them here written for us. Step 1 is to replace f of x with y. Step 2 is to switch x and y. So I put x where y is and y where x is. Now, step 3 is to solve for y. So the first step in getting to a variable when it's inside a parenthesis is getting rid of that 3. That makes that cancel. So I have 1/3 x equals y minus 7. And now I can add 7 to both sides. I get 1/3 x plus 7 equals y. This is all step 3. And step 4 is to replace y with f looks like to the -1 of x. So I said that's how you read it, which isn't exactly right. That's how I say it to get you to write it correctly, but really that we read that as the inverse of f of x. So when we write it, we write f to the minus 1 of x, but when we read it, we should say inverse of f of x. Okay, I'm almost out of time, but I want to go ahead and do example 4 real quick. This is asking us to graph the function itself, which is a line. If you look at this, you can tell it's a line, so let's put it back into a format from chapter 3 that you should remember. Y equals negative 1/2 x minus 5. And we're going to graph that line, and then we're going to write and graph the inverse. So we're going to follow the same steps we just did. Replace y with f of x. Okay, back up a step here. It's already in y. We're going to replace x with y and y with x. And then solving for y, we add 5 first. And then we multiply by negative 1/2, or negative 2, excuse me, in order to get rid of that fraction. Okay, remember we're trying to solve for y. We're on step 3. So in order to get rid of that fraction, I'm going to multiply by negative 2. And all of that cancels, and I'm left with y equals negative 2x minus 10, distributing that to both sides. And my final step is to rewrite it as f to the minus 1, or the inverse of f of x. Now we're going to graph both of these. I'll have to remind you how to graph tomorrow. Here's the answer. So here's a picture of the answer. Just remember that when you graph lines, you start with the y-intercept. In this case, it's negative 5. You put a dot. And then you go down 1 over 2 and put another dot. Up 1 over 2, put another dot, connect. So obviously this light gray line is f of x. Please label yours when you graph. The black line is the other graph here, which has a y-intercept of negative 10 and an x-intercept of negative 5. So you're going to call this one g of x. Alright, when you're finished watching this, you do have an end grade quiz. So go to end grade and take the quiz. Please take your time because you can rewatch this video. Your grade will count, whatever you get, so take your time. See you tomorrow.